Compared with 1 plus 0 non-protection, 1 plus 1 space diversity, SD, significantly improves the anti-fading, especially anti-multipath fading, capability and reliability of microwave links. So, what is 1 plus 1 SD protection? 1 plus 1 SD protection is a 1 plus 1 protection mode. 1 plus 1 SD uses two antennas at different heights to receive the same services. The receive end selects the channel with better quality service signals. 1 plus 1 SD reduces the impact of transmission fading on signals. A microwave system with 1 plus 1 SD protection consists of three ports: main channel, standby channel, and service access unit that receives and transmits services from and to the main and standby channel. In normal cases, the standby channel at the transmit end is muted. Services received by the service access unit are transmitted to the receive end over the main channel. The main and standby channels at the receive end receive the same services through two antennas. The standby channel transmits the received services to the main channel through a cascade port. The modem unit of the main channel compares the received microwave frames, selects the microwave frames received by the main channel directly from the transmit end, and extracts and transmits service signals to the service access unit. When the microwave signals received by the main antenna at the receive end degrade, the signals received by the standby antenna may not degrade due to SD results. In this case, the service access unit selects the service signals received from the modem unit of the standby channel, thereby implementing service protection. In addition, 1 plus 1 SD protection supports 1 plus 1 HSB protection switching. If two RTN 300s form a 1 plus 1 SD protection group, one is the main channel and the other is the standby channel. Other devices are used as service access units. To negotiate the active standby states of microwave channels, the two RTN 300s must be connected using cascade ports. The next is system configuration. Depending on the type of device used as the service access unit, a 1 plus 1 SD system can use the optical splitter mode or the LAG mode. First, let's look at the optical splitter mode, in which optical splitters serve as service access units. In the example, one optical splitter, two RTN 300s, and two single polarized antennas form a 1 plus 1 SD system. The optical splitter can send two channels of signals but receive only one channel at a time. To ensure that services are normally transmitted and received, the access port on the current standby RTN 300 is always disabled. When the main RTN 300 is the active one, its access port is enabled, but the access port on the standby RTN 300 is disabled. When the standby RTN 300 changes to the active one, its access port is enabled, but the access port on the main RTN 300 is disabled. In the example, protection is provided for one channel of GE optical services received. Protection can be provided for multiple channels of GE optical services by increasing the number of access links. To provide protection for multiple channels of GE optical services, an optical splitter must be configured for each channel of services. Note, due to port restrictions, the RTN 310 does not support protection for multiple channels of GE optical services received. Now, let's look at the LAG mode, in which IDUs or customer devices supporting LACP serve as service access units. In the example, one IDU serving as the service access unit, two RTN 300s, and two single polarized antennas form a 1 plus 1 SD system. The IDU forms lags with the main and standby RTN 300s so that the IDU always transmits services to or receives services from the current active RTN 300. When the main RTN 300 is the active one, the system priority of the lag configured on it changes to the highest. Therefore, the lag setup between the IDU and the main RTN 300 works. When the standby RTN 300 changes to the active one, the system priority of the lag configured on it changes to the highest. Therefore, the lag setup between the IDU and the standby RTN 300 works. Lag for RTN 300s in a 1 plus 1 system is called ELAG. For details, see ELAG. In the example, protection is provided for one channel of GE optical electrical services received. Protection can be provided for multiple channels of GE optical electrical services by increasing the number of access links. To provide protection for multiple channels of GE Optical Electrical services, a lag must be set up for each channel of services, and lag status switching must be performed simultaneously depending on the main standby status of RTN 300s.